Hello, everyone. This is Yan Zhang. I'm the instructor of the course CSE 2020. In this video, we will start Module 2, Linked Structures. We have 4 videos in Module 2. The first video, this video, will introduce linked structure and compare linked structures and arrays. The second video will talk about how to insert a new node to a linked structure. The third video will talk about traversing the linked structure to search a node. The last video will discuss deleting a node from a linked structure, and we will take a look at 3 examples. The linked structures. The learning objective of Module 2 linked structures is this. After we complete this module, you are supposed to be able to implement linked structures, including insertion, search, traversal, and deletion operations. Linked structure. What is a linked structure? A linked structure is a set of data linked together by pointers. We have linear linked structure and non-linear linked structures. In this course, we will focus on linear linked structures. So if I say the linked structure, and I mean the linear linked structures. This is an example of the linked structure. In this linked structure, we store a collection of integers. Here, each one, we have some box here. This box, we call it node. This is a node. Now, in this example, we have 4 nodes. And in a node, we store the data. Here, the data is an integer. We store data. We also store the pointer, a pointer. This pointer points to next node. So in each node, we store data and a pointer. This pointer points to next node. The pointer is an address. So this address is the address of next node. We also can store the character in this linked structure. A, B, C, D, or we can store point object in this node, and we can store the point object 1, 1, and point object 2, 2, point object 3, 3, point object 4, 4 in this linked structure. Or we can store a collection of employees in this linked structure. For the employee, we have the ID, name, and the department name. So we can store a collection of employees in this linked structure. Now let's take a look at how to implement the linked structure. We use structs to implement the linked structure. So in fact, we use struct to implement the node type. This is the node type. Node type, we talk about the structs in the module 1. Struct is is a special class. In this special class, all the attributes are public. So always say a struct is a class with public attributes. In a struct, the default access specifiers is public. So now in this struct, I don't write any access specifiers. That means the attribute data is public. The attribute next is public. These two constructors are public. This struct name is node type. The struct name is node type. It has two attributes. It has two attributes, data and next. The data type is int. In this example, we use link structure to store a collection of integers. So the data type is int. This is the element type we will store in this linked structure. And another attribute is next. Next, this is a pointer. This is a pointer because we add a star here. So next is a pointer. This pointer points to node type object. This is a node type struct. So the next will point to a node type object. The node type object, we also call it a node. Node type object. We call it a node. So this is a node. This is a node type object. This is a node. And here the next is a pointer. A pointer is also a variable. It stores an address. So here the next, it stores the address of next node. We have multiple nodes in the link structure. The next store the address of next node. Or we say the next point to next node. This is two attributes. And here we also have two constructors. This is a default constructor. Because this constructor has no parameters. The parameter list is empty. This default constructor will assign data as 0. Next is no pointer. And then a constructor with one parameter. Node type int d. This is a constructor with one parameter. This constructor will set attributes data value is parameters value. And next attribute next value is no pointer. So this is called the initializer or the initialization list. And now this data parentheses d, this means we set the attribute data equal to d. This data is attribute, d is parameter. We pass an integer to this constructor. This constructor will set attribute value as d. Okay, this is a node type struct. And now now I will open a new page. Okay, no. this is a node. In this node, the data is 300. And next is a pointer, or we say the next store an address. So it store an address. This is the address of another node, or we say this is the address of next node. So normally we draw arrow. This arrow points to next node. Okay, now I've opened a white page, empty page. And now we have the struct node type. Now, if we have this statement, we have the statement node type star p1 equal to new node type 100. What does it mean? The new operator will create a node, and the node data is 100. So that means this statement, the new operator will create a node, and the node data is 100. This is the data, and this next. And now this use a constructor with one parameter. So that means the data equal to 100, and next is no pointer. Next is no pointer. And then we write another one. If we have the node type star p2 equal to new node type. What does this mean? This means we create another node, use default constructor. Okay, down the p1 point to this. And now the p2 point to this node. And this node is created use a default constructor. Default constructor set data as 0. And next is no pointer. And now we can add it to we can modify the data of the second node. So we can use a p2. We can use p2 data equal to 200. P2 data equal to 200 means we change this data from 0 to 200. We update the P2's data. This means default constructor. Okay, then we need one more node. Data type star P3 is equal to new node type 300. And now we create the node 3, the third node. The data is 300. And the next is no pointer. P3 is a pointer point to this node. So here we use a new operator create 3 nodes. The first one, the P1 point to the first node. And P1 is a pointer. P1 stores an address. So the P1 stores the address of first node. Now, assuming the first node, its address is AA10. Now, assuming the first node, its address is AA10. This is a hexadecimal address or the hexadecimal value. So the P1, if we print P1, P1's value is AA10. P1 is a pointer. P1 stores an address. Here is a node type. So the P1 store the address of the node 1. So the P1's value is AA10. And now assuming the P2, the address is this. The node 2 address is AA20. And the P3, its value is AA30. Now that means P2 store the address of second node. So the P2's value is pound AA20. And the P3, it store the address, its value is AA30. So the P1, P2, P3, they are pointers. They store addresses. They store the addresses of nodes. And now the P1, this is the P1's value. What is the star P1? What is the star P1? Star P1 is a node 1. 100 and no pointer. Star P1, this star is a dereference operator. Star P1 is the object stored in this address. So the P1 store an address. Star P1 is an object stored in that address. And what is the star P2? Star P2 is a node. The second node is a 200 and no pointer. And what is a star P3? Is the node stored at this address, 300, no pointer. And now if we want to access the data and next in this node, we can use a P1, P2, P3, they're pointers. So we use a P1 arrow data to access 100. We can modify the P1 data, use this. And if we want to access the next attributes, we use P1 next. So here we can access data and next directly because data and next are all public attributes defined in node type. They're public, so we can access this data and next directly. And now we have 3 nodes. Now we want to use pointers to link them together. So I will write these two statements. P1 next. Now what is the P1 next? Now the P1 next is no pointer. Is no pointer. This means the no pointer. This no pointer. It points nothing. Now we want to update this address. So the P1 next is a pointer. it stores an address. Now we want this P1 next store the address of second node. The address of second node is this AA20. Okay, so this address is stored in P2. So we will set the P1 next equal to P2. So that means we will assign P2's value to P1 next. What is P2's value? P2 value is this, AA20. So now we will modify P1 next. P1 next is not the null pointer anymore. So we will use we will assign P2's value to P1 next. P2's value is AA20. So now we put the AA20 to P1 next. So we assign P2's value to P1 next. That means we copy P2's value AA20 to P1 next. So now this means this P1 next store the address of second node AA20. And then the next statement, we read the P2 next equal to P3. Now, what is a P3's value? P3's value is AA30. Is the address of third node. Now we will assign this address to P2 next. Now the P2 next is a pointer, it's a null pointer. Now we will change this. It's not the null pointer. We will put the AA30 to P2 next. So now that means the P2 next is the address of third node. Now we connect these three nodes together. P1 data is 100. P2 next point to P1 next point to the second node. P2 next points to the third node. So normally we don't write the address. We draw the arrow. So the P1 point to the second, P1 next point to the second node, and the P2 next point to the third node. Okay, we draw like this. Okay, so we don't write the specific address. We just draw the pointer point to next node. And now the P1 point to the first node in the link structure. And the third node is the last node in the link structure because its next is null pointer. So given a link structure, we need to know the address of first node. Normally, we use a head. Head is a pointer pointed to the first node. So at least in this course and in this module, we always use a head pointed to the first node of the link structure. And this is the first node. Last node, the last node, its next is null pointer. Okay, this is a linked structure. In this example, we store the integers, and we also can store the point object in the data. Okay, now if we go to the next page, okay, if we go to the next page, so now this is in this node type. In this node type, the data type is point. The data type is point. In this node type, we have two public attributes. Two public attributes. The attributes data, its type is point. This is a point class. So that means in this linked structure, we will store a collection of point object. So we will have a head point to the first node, and the data then is a point object. This is the next point to the next node. And then etc. We have many nodes here. It's this is a 100, 100, the last node. The last node, the next is null pointer. Okay, similarly, we can define a linked structure to store a collection of employee object. So we will use the employee data. The data type is an employee class. And if we modify the attributes type, we also need to modify the parameter type passed to the node type constructor. So if we change this to employee, this also will be the employee. Okay, this is how we implement the linked structure. And now let's compare the linked structure and array. Now we know before we introduce the linked structure, we can use array to store a collection of elements. So we have array. And this is a linked structure. Arrays and the linked structure. Array and linked structure, they all can store a collection of elements. Now, what's the difference between these two? And the array, when we declare array, no matter it's normal array or dynamic array, after we declare the array capacity is fixed. Okay, the array has a fixed capacity. And for the normal array, for example, we have the int a 100, or we have the dynamic array int star p equal to new int x. So no matter which one, the normal array or dynamic array, and after we declare the array capacity is fixed. And that means after we declare the array, we cannot expand or reduce array capacity. But for the linked structure, there's no fixed capacity for the linked structure. Okay, there's no fixed capacity. We can add as many as element or as many as nodes in the linked structure. It depends on the memory space. So the linked structure itself has no capacity. The memory space, the size of memory space is the limit of the linked structure. And then the next difference is the array is stored in the consecutive memory space. Okay, the array is stored in the consecutive memory space. Consecutive memory space. So that means if we know the address of first element, we can know the address of all the elements in the array. For example, if we have array, it's we have an array, its capacity is 100. So the address of first element or the A, it's a value, or the address first element is A10. The second element, its address is what? Is this is the int. So the address of the second element is 14. The third one is A18, etc. So we know the address of first element, we can know the address of all elements in the array. But for the linked structure, it's not true. We know the address of first node, and we don't know the address of other node, because these multiple nodes are scattered in the memory space. Scattered in memory. And we know the address of first node is A10. The second node is not consecutive with the first node. And the second node can be stored in any place in any address in the memory. So the second node, we don't know. So this is a difference. The array stored in the consecutive memory space, but for the linked structures, the nodes are scattered in memory. Okay, so because this reason, the array support random access. So that means if we want to access the 10th element in the array, if we want to access the 10th, the element at the index 10, or this is not the 10th, this is the I will say that if we want to access the element at index 10, we can directly access it, so that we know the address of first node and we can directly access the element at the index 10. But for the link structure doesn't support the random access. It has a sequential access. So that means this is the link structure. If we want to access the element in the middle, we have to start from the first element. We have to start from the first node. Now, if we want to access this node, we have to start from the head, from first node, and the first node next, go to the second node, and then next, go to the third node, and then next, go to the fourth node. So that we cannot directly access the fourth node in this link structure. We have to start from the first node, move to next, move to next, move to next, until we reach the fourth node, the middle node. So this is the sequential access, but the array is a random access. We can directly access A10 or A99. We don't have to go from A0 to A1 and then to A99. No, it's not necessary. So the array support the random access. But now the okay, another difference between array and link structure is memory, the size of memory they need. Because in the array, we only store data. But in the link structure, in the node, we store data and address of next node. Now, assuming we have 1 million integer numbers. Now we want to store 1 million integer numbers. If we store this 1 million integer numbers for array, we need 4 million bytes. One integer need 4 bytes. So 1 million integers, we need 4 million bytes to store these integers. This is the array size. Array need 4 million bytes. But if we use a link structure, and data need 4 million bytes, and address, we need 8 million bytes. Because address is a very large integer number. Nowadays, we have the 64-bit computer. The address has 64 bits. That is 8 bytes. So that means we need 8 million bytes to store address. So the link structures need more space than arrays, because the link structure need to store the data and address. The array only need to store data. Okay, this is the difference between array and link structure. And this video, we will stop here for this video. And next video, we will talk about how to insert new nodes in a linked structure.